The next test that we're going to do is a single sample t-test. So again, we're going to get some data from the samples. And we're actually going to get the data that I used in class. And so this is a set of data that describes parts of a brake that are machined in a parts factory. And each brake is supposed to be exactly 322 millimeters in diameter. These are discs. So each disc is supposed to be exactly 322 millimeters in diameter. So we want to use a single sample t-test to see if any of these machines are consistently large or small. So let's try machine 4 here. So first I'm going to filter my data, so I'm only looking at machine 4. So go Data, select Cases, and I'm going to select cases if the condition is satisfied. So I'll do if, and then we're going to look at the machine number, and then we're going to say the machine has to be equal to 4. So we hit OK, or continue, and then we hit OK. Now I can see that non-4 entries are unselected, and 4 is selected. And there's this dummy variable, which is the result of that computation we just put in there, the machine equals 4. And so it's equal to non-selected, which is 0, or selected, which is 1. So that's the result. So now we can compute our single sample t-test. So we'll go Analyze, Compare Means, One Sample t-test. And our single sample is the disc brake diameter, and the test value is 322. And that's it. So we hit OK. So the sample mean is 321.99, which is close, really close to 322, but it is many standard errors away. In fact, it is 2.6 standard errors less. That's what this negative t-score means. And so the probability of observing a t of minus 2.6 and from a distribution of with 15 degrees of freedom is only 2 in 100. So we would reject the hypothesis that this machine is producing discs with an average diameter of 322. We say this disc is producing discs that are too small. This machine is producing discs that are too small. So we would reject the null hypothesis. So how will we visualize this? Well, we would make a graph. And I think for a single sample t-test, I have decided that what I really like are box plots. So we'd make a box plot. And we would drag disc brake diameter here. And get rid of the title. I don't like titles. And we need to fix the x-axis, because right now this would show all the different machines, and then it'd be an empty column for the machines that weren't 4, and then only 4 would be visible. So we're going to tell the x-axis to only show the categories that are present in the data, just machine 4. And the y-axis, we're going to leave that alone. I think that will be lovely. So we hit OK. So now we have this sweet box plot where you have the mean, and you have, well, actually this is the median and this first and third quartile, and then some extras sort of showing how broadly spread out your data are. So here's 322 nicely here, showing us where the mean was, and so it's not quite overlapping the mean. So we say it is significantly less. So just to make this extra pretty, I'm going to add a reference line. We'll add a reference line here. We'll add it at 322 millimeters. We'll put a label there and apply. There it is. So that emphasizes that our thing that we're aiming for is here, And then looking at these, it looks like we can maybe shave off a couple of decimal places in the number format. So we'll do 2 decimal places rather than 4. And we'll apply that. And that looks a little neater. Close. Close. And now we're ready to paste this sucker into Word. So we copy that. Word. Paste it in there. And then we say the machine. So we say machine number for produced disks that were significantly smaller than average in their that were on average significantly smaller than 322 millimeters. Mean plus standard error equals here mean 321.995 plus 0.00175. Is that right? Yep. Millimeters. T sub 15 equals minus 2.613. P equals 0.020. There we go. Minus sign really doesn't carry over, huh? What can you do? You can make the whole thing a little bit bigger so it wraps more curly. There we go. Glorious. All right. So there's our results. And that's how we would report the single sample t-test that we just carried out.